Alright, so in this video, we're going to talk about something called least common multiple, which is also known as LCM. In the last lesson, we looked at greatest common factor. Least common multiple is kind of the opposite of factoring, which we'll look at just a minute, but prime factorization or factor trees are still very, very important. So please make sure you've mastered those before you do this lesson. So what is a least common multiple? So the least common multiple is the smallest number that is a multiple of two or more numbers. And so I want to show you an example of that. So here I have the number 5 and I have the number 11. With greatest common factor, we would break these down into factors, so into numbers that would go into them. But with multiples, what they're asking you for is the pattern of numbers. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So something like that. And then with 11, we would go 11, 22, 33, 40. Oops, I did that completely wrong. Not 43. Let's try 44. 55, 66, and on and on and on. So with greatest common factor, I was asking you for the biggest number, the greatest number that was a factor of both numbers. With least common multiple, I'm asking you for the least, the smallest number that's a multiple of these two numbers. In this case, with 5 and 11, it's going to be 55. Now, as with greatest common factor, if you feel more comfortable listing out the multiples just like this, that is completely fine. But there is an easier way that I'm going to show you. However, please feel comfortable to do it any way that you wish. So, just like with greatest common factor, I have a T-chart here with the two numbers. And just like with greatest common factor, I'm going to start out by making a factor tree. So with 6, I have 2 and 3. And with 9, I have 3 and 3, okay? So again, what I'm trying to find is the smallest number that is a multiple of these two numbers. Now, instead of crossing out the pairs and bringing them over, the way that you do LCM is you are going to actually multiply the factors out on top of each other. So remember that that dot means times. You can write a times sign if you want. That's fine. So here I have 2 times 3 for the factors of 6. Now the factors of 9 are 3 times 3. I'm going to put the first 3 under the other 3, and then I have another 3 over here. So what I did is the prime factors that match, I put them underneath each other. Now I'm done, and all I do now is I bring each number down. So 2 times, and I'm only going to bring down 1 3 here, times, and then I'm going to bring down this other 3. Now I multiply this out. So 2 times 3 is 6, times 3 equals 18. And so my LCM is 18. So it's the same exact process as finding the greatest common factor, except instead of finding the pairs and bringing them over, I'm going to multiply out all the prime factors. All right, so here let's find the LCM of 8 and 20. So I'm going to make my factor tree for 8. I have 2 times 4, and with 4 I have 2 times 2. Over here with 20, I'm going to do 2 times 10, and I'm going to do 2 times 5. Okay, now I'm going to take my 8 first and write out my prime factors here. And then I'm going to go to the 20. Now I have 2 times 2 times 5. So I'm going to put 2 of the 2's under the other 2's, and the times 5 is going to be on its own. Now I'm going to bring down what I have. So I'm literally bringing it down just like this. So 2, and then I'm going to bring these down. 2 times, then I'm going to bring these down. 2 times, and then I'm going to bring the 5 down. 5. And now I just multiply it out. 2 times 2 is 4. 2 times 5 is 10. 4 times 10 is going to be 40. So if I were to find the multiples of these two numbers and I would list them all out, the smallest number that they're going to have in common is 40. All right, now here's an example with 3 numbers. three numbers, the process is going to be exactly the same. So let me show you. So I'm going to make my factor tree for 4. So I'm going to have 2 and 2. Now with 5, 5 is a prime number, and so my factors are 1 and 5. And then with 8, I'm going to have 2 and 4, and I'm going to break down that 4 into 2 and 2. Okay, so I'm going to start with my 2 times 2 with my 4 over here. So 2 times 2 is 4. Now I have this 1 and 5. I don't have any matches here, so they're going to come out to the side, 1 times 5, because I can't put them directly under. And over here I have 3 2's. And so I'm going to kind of go like this. So your format does not matter too much as long as your matches are going underneath each other. Now this is a very important point that I'm about to make. When we did greatest common factor, if you'll remember, I had to have a match in each column in order to bring it over to the multiply column. Here, I do not need to have a match of 2's 3 times in order to put them over each other. All I have to do is have a single match. And so I'm going to bring this column down 2 times, and then this column down 2 times, and then this column down 2 times, and then I have my 1 times, and then my 5. And I multiply this all together. So 2 times 2 is going to be 4. 2 times 1 is 2, and then I have my 5. 4 times 2 is 8, and 8 times 5 is going to be 40. So if I listed out the multiples of 4, of 5, and of 8, I would get to 40. Now, I want to pause here and tell you the advantage of doing the chart like this with the factor trees. When you have a number 4, 5, and 8, and you're listing out the multiples, chances, well, not chances are, but there is a chance that you will make a mathematical error into one of your multiples. Once you make an error, so for example, if you did 4, 8, and instead of 12, you accidentally put 13, now you add 4 to 13 and you get 17, you have now completely thrown off your entire process. And so you may be listing multiples forever and ever, and you'll never get to the right answer. So the advantage of the factor trees is that there is less room for mistakes. Okay, let's look at another one with 3 numbers. So here I have 5, and so the prime factors for 5 are 1 and 5. I have 10, which is going to be 2 and 5. And then I have 12, which is 2 and 6. And then 6 breaks down to 2 and 3. All right, so I'm going to list them out here. So I have 1 times 5. And then over here I have a 5 times 2. And you might have noticed here, like I flipped it, I had the 5 first and the 2 second. That's okay. If you need to do that to like make it a little neater, that's fine. And then I have 2 2's and a 3. So I'm going to do 2 times 2 times 3. All right, so now I'm going to bring them down. So I'm going to bring down the 1 times and the 5 times and the 2 times and this other 2 times and this 3 times. All right, so 1 times 5 is 5. 2 times 2 is 4. And then I have this here. So then 5 times 4 is 20, and 20 times 3 is going to be 60. So again, that was a much, much quicker process than sitting here and listing out the multiples of 5, of 10, and of 12. However, I do want to stress, if you're not comfortable with this method, you always have the option to list out the multiples. Okay, you go ahead and try this one. I'm going to solve it at the same time, and then we will compare answers. right, so if you're not done, go ahead and pause the video so that you can continue solving the problem. So this is a really good example as to why this method can be helpful. Our LCM turned out to be 108, and that would have been a lot of listing of numbers for you. Now, remember that your prime factor trees may look a little different in terms of how you split them up, but the prime factors that you got should be the same. So you should have had 2, 2, 3, and 3 for 36, 2, 3, 3, 3 for 54. Okay, and you can take a look at how I did mine if it helps, but you should have ended up with an LCM of 108. All right, go ahead and try these two numbers. All right, if you're not done, go ahead and pause the video. So for the LCM of 12 and 20, you should have gotten 60. And again, your factor trees may look different than mine, but you should have still ended up with the same prime factors. So for 12, you should have ended up with 2, 2, and 3. And for 20, you should have ended up with 2, 2, and 5. Now you'll see that when I went to multiply them here, I had 2's that match, and then I didn't have a match with a 3. And then I had an extra 5. So it's okay to go ahead and skip a spot like that. That's not a problem at all. All right, go ahead and try the LCM of these three numbers, 18, 24, and 72. All right, so for these three numbers, the LCM was 72. Now, the hardest part with this problem definitely was the amount of 2's that you ended up with as prime factors. But as long as you leave yourself more than enough space, you should be able to align them very nicely. It also helps if you see me draw these arrows. You could also get yourself a highlighter and highlight the row as you bring the number down. You just want to make sure that you're not forgetting a number. All right, that is the end of this lesson. We're going to practice more LCM in class, but please make sure you ask me if you have any questions.